Okay, in this video we are going to do a trig substitution example where we have to introduce the radical before we can even kind of get going. And then after that there is just a lot going on. So let's take a look at the problem, which looks pretty harmless to begin with. It's the integral of dx over the quantity 1 plus x squared cubed. So there's no radical in here, but it feels like something that I want to use trig substitution on. Usually I look at it and I think in a perfect world that would have been arctan. But it's not, so I'm going to try trig substitution because sometimes that introduces that concept. So what I'll do is I'm going to do dx, and then I'm going to change 1 plus x squared into radical 1 plus x squared squared. And then the radical and the squared would cancel out and we'd get back to the original, and so we have this, and then it's the radical squared and then cubed. So this we can rewrite as dx over, we have our radical, and then it's to the 6th, right? Because it's squared and then cubed, and then you multiply them and you get to the 6th. Okay, so now we just have a trig substitution problem. So I see a radical, I'm going to draw a triangle. And in this case I have radical 1 plus x squared, so that should be the hypotenuse. And then the legs, therefore, would have to be 1 and x, and I'm going to put x opposite the angle. So I have x and 1, I need an angle. And from here I want to kind of figure out my ratio. So you, generally speaking, don't want to use a ratio that would involve both of the parts that have x involved. So I'm going to say that secant of theta is the hypotenuse over the adjacent side. So that's actually just the radical, 1 plus x squared. And then I'm also going to use tangent, which is opposite over adjacent. So tangent of theta in this case is just x. And since tangent of theta is x, I can find dx at this point. So that's, people tend to forget to substitute for dx. So dx is going to be secant squared of theta d theta. Okay, so that's all I get from my triangle, and I want to go back to the original integral, well no, the rewritten integral, and make my substitution. So the first thing I need to substitute for is going to be dx. And to substitute for dx, I know that dx is secant squared of theta d theta. So I have that, and then that's going to be over, I need to substitute for the radical, and if I look, I know that the radical is secant of theta, so it's going to be secant of theta to the 6th. And this isn't bad at all, because this, if I simplify it, I get d theta over secant to the 4th, but I would much rather work with the reciprocal of secant, which is cosine to the 4th. Okay, so now I need to know what to do with cosine to the 4th. So if you have an even power of cosine, you usually want to use the power reducing formula, and that looks like cosine squared of x is 1 plus cosine of 2x all over 2. So I'm going to use the power reducing formula because I have cosine squared squared. I'm going to get the quantity 1 plus cosine of 2x over 2, or 2 theta I guess, and then squared. And there's really nothing to do here but expand. So that denominator is 2, you square it, you can pull out a 1/4. So I have 1/4 the integral of, and now I'm just expanding, so it's 1 plus 2 cosine of 2 theta, and then plus cosine squared of 2 theta. And this is actually really a common thing that will occur if you're integrating powers of trig functions, so you've probably seen something like this before. So from here, I can actually integrate that part, so I'm just going to do that. So it's going to be equal to, I get 1/4 theta, and then the 1/4 and the 2 cancel to just give me 1/2. And then if I integrate cosine of 2 theta, that's 1/2 sine of 2 theta. So we're here. And then this is going to require more work, so I'm just going to write plus 1/4 the integral of cosine squared of 2 theta and d theta. And I'm kind of out of space, so what I'm going to do is copy the relevant stuff to another page and keep going. So this is where I currently stand. So I can simplify this stuff, so let's just do that. And then it's going to be plus 1/4 the integral of, well now I have cosine squared of something again, so I'm actually just going to go back to this formula, except in this case, instead of having cosine squared of x, I have cosine squared of 2 theta, so that should be 1 plus cosine of 2 times 2 theta, or cosine of 4 theta, all over 2. So it's 1 plus cosine of, so it's 2 theta, so it's 2 times 2 theta, which is 4 theta, and then that's all over 2 d theta. Okay, let's keep going. So you get 1/4 theta plus 1/4 sine of 2 theta, and then plus 1/8, right? And then it's the integral of 1 plus cosine of 4 theta d theta. Alright, so far not terrible. You just have to remember the power reducing formula. So this will be 1/4 theta plus 1/4 sine of 2 theta plus, now I can start integrating. So it's the integral of 1 is theta, so it's plus 1/8 theta. And then the integral of cosine of 4 theta is going to be 1/4 sine of 4 theta, but there's another 1/8, so it's going to be 1/32 sine of 4 theta. And then plus c, right? Because I'm getting there, right? I've integrated. There's no more integrals, so now it's actually going to be kind of an annoying pre-calc problem. So I'm going to copy the relevant information and start on a new page. So here we are. Okay, so this can just be simplified right off the bat, right? I have 1/4 theta and I have 1/8 theta. So let's simplify that before we get too involved. This is not a big simplification, but it's a little simpler. And then plus c. Imagine forgetting plus c at the end of this. Alright, so I have sine of 2 theta and I have sine of 4 theta that I need to deal with. So sine of 2 theta, I remember from pre-calc, or math analysis if you're in my school. Sine of 2 theta is 2 sine theta cosine theta. Okay, and then, so that's going to be 2. Go back to the triangle that you have, and you can see that sine of theta is opposite over hypotenuse, so that's going to be x over our radical. And then cosine of theta is adjacent over hypotenuse, so that's going to be 1 over our radical. Which means that sine of 2 theta, eventually I'm going to substitute for that, and I'm going to substitute 2x over 1 plus x squared. Now I need to deal with sine of 4 theta. So sine of 4 theta is a little trickier, but not really. So sine of 4 theta is going to be the sine of 2 times 2 theta. So I've chosen to break it up this way. And that's going to be 2 times sine of 2 theta times cosine of 2 theta. And I already found the sine of 2 theta, so I don't want to keep going with formulas there. I just want to say that this is equal to 2 sine of 2 theta. I haven't found cosine of 2 theta, so I need to remember a formula for that. Looking at the triangle, cosine of theta is much simpler, well not much, but it's simpler than sine of theta. So I'm going to use the cosine of 2 theta formula that just involves cosine, and that is 2 cosine squared of theta minus 1. So you got to remember all these formulas. So now let's substitute some stuff. So it's 2 sine of 2 theta we just found, it's in the box, 2x over 1 plus x squared. And now it's going to be 2 cosine of theta is 1 over radical 1 plus x squared, so cosine squared is just 1 over 1 plus x squared. So I get 2 over 1 plus x squared and then just minus 1. And so that's going to be, we can simplify this. So I'm going to get a common denominator and kind of expand across the numerator, but not really. I've got 2 times 2x is 4x. And then I'm getting the common denominator in that second set of parentheses. So it's going to be 2 minus the quantity 1 plus x squared, so 2 minus 1 minus x squared, so 1 minus x squared. Kind of assuming you can do some algebra. I mean, if you're running into this integral, you can probably do some algebra. And then the whole denominator is actually the quantity 1 plus x squared squared. And so that's sine of 4 theta. It's pretty easy to lose track of why we're doing this. We're trying to substitute back into our antiderivative so that it's in terms of x. So we're close. So again, we're going to take all the relevant stuff and I'm going to put it on a new page and go from there. So here's everything we have. And alright, let's substitute. So we've got equals 3/8. I need to substitute for theta. The easiest thing to do is you go to our triangle box there and you see tan of theta is x, so I'm just going to go with the inverse tangent of x plus 1/4. We found the sine of 2 theta to be the quantity 2x over 1 plus x squared. And then plus 1/32. We found sine of 4 theta, so I'm going to substitute there. Get 4x, the quantity 1 minus x squared, over the quantity 1 plus x squared squared, and then a plus c. Okay, so now I want to keep you're kind of done at that point, if you're willing to be done there. I'm going to keep simplifying. So the 3/8 arctan, nothing can be done with. But all this algebraic stuff, if I were to get a common denominator, it looks like it would be 8 times the quantity 1 plus x squared squared. So that's what I'm going to go for here. I'm looking for a common denominator. It's going to be 8, the quantity 1 plus x squared squared. So this first fraction, I need to multiply by 2 over 2 to get the 8, and 1 plus x squared over 1 plus x squared to get the 1 plus x squared quantity squared. So if I multiply by 2 over 2, that gives me a 4x. If I multiply by 1 plus x squared over 1 plus x squared, it's going to give me another 1 plus x squared, and then all over 8 times the quantity 1 plus x squared squared. Okay, and then the next fraction, really all I need to do is cancel the 4 and the 32. And then I'm also just going to write it down. There's no also there. Forgot what I was doing. And then plus c. Okay, so we're really close. So we've got 3/8 arctan of x, and then plus, so when I'm combining them, I have, in the numerators, I have 4x from the first fraction, and then plus x, so that's going to be 5x. I have 4x cubed, and then minus x cubed, so that's going to be plus 3x cubed, and then all over the denominator. And then plus c. And then finally you can, I mean, I don't know why you do this, but you can factor a 1/8 out, and you can also, from the fraction, factor an x out, and kind of rewrite it, and get this. 1 plus x squared plus c. And that's it, okay? That's our answer. So why did I keep going? I basically kept going because I checked my answer on Wolfram Alpha, and it wrote the answer that way. But that's it. So it was a lot of work. It's basically the reason that you take Algebra 2, Pre-Calculus, Calc 1, and then get to these integrals. I hope you found this helpful, or at least enlightening, and good luck.